Section 3.6, and we're talking about polygon angle formulas. And the first formula that we want to talk about, for this first one, we are talking about the sum of interior angles. And just as a reminder, sum means all of them added together. So we're adding, we want to figure out how we can figure out when we add all of the interior angles and measure the interior angles of a polygon, when we add them together, what does that add up to? So I'm going to start out with a little demonstration. So I'm going to draw some shapes, and we're going to figure out a few things about these shapes. So for this first shape, how many sides do we have? 3. And if we add all of the interior angles and measure the interior angles together, what does it add up to? 180 for a triangle. How many triangles do we have here? 1. All right, let's do a 4-sided shape. So there's a 4-sided shape. And what I'm going to do is divide the shape into triangles. So I'm just going to draw across like so. Now, how many sides do we have in this shape? 4 sides. How many triangles was I able to divide it into? 2. 2 triangles. Now, can we agree that if I added all the angles in this triangle plus all the angles in this triangle, I would be adding together all the angles inside this 4-sided shape? Because these two together make this one big angle, and those two together make that one big angle. So if I add all the triangles, the measures of the angles of the triangles together, I would get all the angles inside this 4-sided shape. So what would all the angles add up to then? 360. All right. Now we're going to do a pentagon. So here's my pentagon, and I'm going to divide it into triangles again. All right, how many sides do I have here? 5 sides. How many triangles was I able to divide it into? 1, 2, 3. And again, if I add up all the angles in this triangle plus angles in this triangle plus angles in that triangle, I would have all the angles inside my polygon. So what do those add up to? I have 180 plus 180 is 360 plus 180, 540. All right, let's do one more. And then what we're doing is looking for a pattern here. So here's a hexagon. We'll divide that into triangles. How many sides do we have? 6. How many triangles? 4. And if I add up all the angles in these triangles, I get all the angles inside my shape. So I have 1, 2, 3, 4 times 180. So I have 180 more than this. 720. Now, do you see a pattern between the number of sides and the number of triangles? What's our pattern here? When I have 3 sides, I have 1 triangle. When I have 4 sides, I can divide it into 2 triangles. 5 sides, 3 triangles. 6 sides, 4 triangles. How are they different? Each of these is different by how much? 2. Each one is different by 2. So if I have a shape, I can divide it into triangles, and I get 2 less triangles than the number of sides. And all the angles inside add up to all the angles inside those triangles. So here I have 2 triangles, I get 360 degrees. Here I have 3 triangles, I get 540 degrees, 3 times 180. Here I have 4 triangles, and they add up to 720 degrees. I get 4 times 180. So our pattern is the number of triangles is 2 less than the number of sides. So if I have n sides, I get n minus 2 triangles, 2 less. And the angles, the sum of the angles, sum of the interior angles is 180 for each triangle times n minus 2 triangles, where n equals the number of sides. So this is our first important formula. The sum of the interior angles of a polygon is 180 times n minus 2, where n is the number of sides. And we figured that out by dividing our polygon into triangles. Go back here. And let me just make a quick sketch. If we have a polygon, what I'm talking about here, the interior angle is right there. And I don't want it to look like a 90. So if I add up all these interior angles, I get 180 times n minus 2, where n is the number of sides. Your keywords when you're looking at a problem like this: sum. Sum means add all together. All. Total. All together. So when you see words like this, the sum, all, total, all together, they are talking about all of them added together. And this is the formula that we would use to figure out the sum of the interior angles. Let me write that a little. Questions on that? All right, so if we have a regular polygon, what did we mean? We talked about regular polygons before. What did we mean when we said we had a regular polygon? What did regular mean? It means something was the same. What was the same on regular polygons? The sides and the angles. So if we have a regular polygon, so that means all the angles are the same. And we know what all of them added together were. How could we find one of the angles? Let's say all the angles, all the interior angles added up to 100 degrees, and it had 10 sides. We knew all of them were the same. 100 divided by 10, we would divide by the number of sides. So that's going to be our next formula, to find one interior angle. So our next formula is the measure of one interior angle of a regular polygon. And regular equals all sides plus angles congruent. So the measure of one interior angle of a regular polygon is 180 times n minus 2, that's all of them added together, divided by n, divided by the number of sides, where n equals number of sides. So this is our second important formula for today. And guys, I guarantee you, if you're not writing these down, if you're not following along, you're going to be lost. So the measure of one interior angle of a regular polygon, 180 times n minus 2 is all of them together, and we're dividing by the number of sides. So this is our second important formula of the day. Our key words for this problem: and, a, one, each. So if we're looking for one interior angle, if we're looking for an interior angle, if we're looking for each interior angle, we're going to use this formula: 180 times n minus 2 divided by n. Now I want to get all of our formulas first before we do examples. So I want to make sure we get all the formulas, and then we'll do some examples. So regular means all sides in all our angles are congruent. So the measure of one interior angle of a regular polygon is given by this formula. All right, so those are our formulas for interior angles. Now we need to talk about exterior angles. So if I have a polygon, let's talk about what an exterior angle is. So here's a hexagon. And what I'm going to do is just extend each of these sides. And we talked a little bit about the exterior angle of a triangle before. But I'm just extending each of these sides. And these angles out here are our exterior angles. So these are our exterior angles out here. We're just extending the sides and making these exterior angles. We're going to state this as a theorem. So our theorem is that the sum of the measures of the exterior angles of any polygon is 360 degrees. So this isn't really a formula, but it's an important fact. We're going to say that the sum of the measures of the exterior angles of any polygon is 360 degrees. So for a regular polygon, if we know that all the exterior angles add up to 360 degrees, and we want to find one, all we have to do is divide by the number of sides. For a regular polygon, the exterior angle, one exterior angle, is 360 degrees divided by the number of sides. So this is our third important formula for today. So for a regular polygon, one exterior angle is 360 degrees divided by the number of sides. The sum of the measures of the exterior angles of any polygon is always 360 degrees. The sum of the measures of the interior angles depends on the number of sides. If we know an exterior angle, if we know one exterior angle, we can figure out the number of sides. The number of sides, it's basically using this formula in reverse. Number of sides equals 360 degrees divided by the exterior angle. So this is our fourth important formula of the day. For a regular polygon, the number of sides is 360 degrees divided by one exterior angle. So we have formulas for the sum of the interior angles, for one interior angle, for one exterior angle, and for the number of sides if we know an exterior angle. Now, does this formula 360 degrees divided by the number of sides look like another formula that we've already worked with? It was on the quiz. What else was 360 divided by the number of sides? You remember? The central angle. Perfect. So let me draw another picture. So if we have a hexagon, this is the central angle. And the central angle for a regular polygon is 360 degrees divided by n also. So for a regular polygon, the central angle and the exterior angle are the same. So this is one that was on the quiz the other day. So just a couple of things to remember. The sum of the exterior angles for any polygon, always 360 degrees, no matter what. The sum of the interior angles depends on the number of sides. All right, so those are our formulas. Let's look at some examples of kinds of problems that we would use, that we'd have to solve using those formulas. So for our first example, here's our picture. And this is 105 degrees. This is 95 degrees. That's a right angle. That's 100 degrees. And that is x. And we want to find x. So what are we going to have to do here to find x? So we have to find out what they all add up to. So let's add up the ones that we know. That's a good start. So I'm going to add 105 plus 95 plus 90 plus 100. So the ones that we know add up to 390. 50 degrees. What do all of the angles have to add up to? 540. And why is it 540?
Because this number of sides times 2 times 2.
Right. We have 5 sides. We subtract 2. That tells us how many triangles are in there. So they all have to add up to to 180 times 5 minus 2. 180 times 3, which is 540 degrees. We know that they all have to add up to 540 degrees. We know that the ones that, so far the ones that we know add up to 390. So 540 to get the missing one, 540 minus 390 equals 150.
150.
So x equals 150 degrees. You were very close. So we know that all 5 of them have to add up to 540, and we're missing one. So this is just like solving problems with triangles. If we're missing one, we can find the missing one because we know what all of them have to add up to. All right, let's look at another example. If we have a regular polygon with 5 sides, what is the measure of an interior angle? All right, so we have a 5-sided polygon. It's a regular polygon with 5 sides. We want the measure of one interior angle. And is our key word. We're looking for one interior angle. Our formula for one interior angle is 180 times n minus 2 divided by n, where n is our number of sides. So we're just going to plug in our numbers. 180 times 5 minus 2 divided by 5. So we get 180 times 3 divided by 5. 180 times 3 is, we already figured that out, 540 divided by 5. And our one interior angle equals 108. 540 divided by 5 is 108. And we could also have said, we already figured out in the problem before, that a 5-sided polygon, a regular polygon with 5 sides, has 540, the angles add up to 540 degrees, and we could divide by 5. So we just did a few extra steps in our equation. So one interior angle of a regular pentagon is 108 degrees. All right, let's work one of these problems going the other direction, where we know the interior angle and we want to figure out the number of sides. This is where it gets a little trickier. So the measure one interior angle of a regular polygon is 140 degrees. We want to know how many sides. So this is kind of like the last problem we did, but worked in reverse. So we know one interior angle is 140 degrees. Well, our formula, one interior angle is 180 times n minus 2 divided by n. Well, one interior angle is 140 degrees. So I'm going to say that 140 equals 180 times n minus 2 divided by n. And our goal here is to solve for n. So what do I have to do first here to solve for n? What's our problem? We have n here in the denominator. We don't want it in the bottom here. We want it in the top. So I'm going to multiply both sides by n. And I'm going to put that here. So I'm multiplying both sides by n, and these n divided by n just gives me 1. So I get 140 n equals 180 times n minus 2. Now what do I have to do? I have parentheses here. What do I have to do with those parentheses? And my n is inside the parentheses here.
So you take it out.
I have to get it out, but what do I have to do to get it out of there? The 2 is inside the parentheses. So what's 180 doing to the whole parentheses? Multiplying. So it's multiplying the whole parentheses, so I need to distribute. Okay? So I get 140n equals 180 times n. And 180 times negative 2 is negative 360. So that's what I get after I distribute. I want to get the n's together. So n's on the same side. So I'm going to subtract minus 180n. And this is where we need to be careful. 140 minus 180 is negative 40. And I have a negative 360 here. This comes straight down. Now how do I get n by itself? Divide by negative 40. And when I divide here, I get n equals, and 360, negative 360 divided by negative 40 is 9. So this would be a 9-sided polygon. This formula, using the formula this way, is what usually people have, they find a little tricky, because we have to multiply by n and then we have to distribute. So this one is a good one to make sure you follow along. All right, we're doing good. I want to do one more example with an exterior angle, and then we're going to make a little chart. We have the exterior angle. Of a regular polygon is 30 degrees. We want to know how many sides. Well, one of our important formulas, we said that the number of sides was 360 degrees divided by 30 degrees. So 360 divided by 30 is 12. So the number of sides of this polygon with an exterior angle of 30 degrees is 12. We just divided 360 degrees divided by the exterior angle. Questions on that example? All right, let's make a little chart for our interior angles, and then we'll be done.
What does this cost about?
55. This chart would be a good thing to write down or just to remember the pattern. So we're looking at the number of sides and the interior angle sum. So we're adding all the interior angles together. So if we have 3 sides, what do all the angles inside a triangle add up to? In the angles inside a triangle, what do they add up to?
180.
180. Four sides, a quadrilateral, what do all the angles add up to? 360. We've done this a couple of times in the examples. What? 540. Six sides? 720. Seven sides?
900.
900.
Oh.
And we'll just go through octagons. Octagons is 1080. And all we do is add 180 degrees. Knock it off, guys. Add 180 degrees each time. So this is a quick way to figure out what the angles inside of a polygon, what the interior angles add up to. If we know a triangle, we just add 180 each time until we get up to the number of sides we want. It gets kind of difficult if we're talking about like a 50-sided shape, but we can figure out 3 through 8 pretty easily just by knowing that we add up 180 each time. And we'll work with these enough that you'll probably remember 3 through 6 by the time we're done. But these are pretty easy to remember. All right, questions? Okay, I'm going to put the homework up on the board here before I pass the folders out, just in case we run short on time. All right, there's the homework. Folders coming out in just a second.